everybody, I'm Dr. Poe, and I just wanted to show you another way to solve some stoichiometry problems. So as we've learned previously, stoichiometry is going to look at two different chemicals and relate them either in mass or moles to another chemical, again, either in mass or moles. And so a lot of students find this concept really challenging. But there's really two tools that we're going to be using to solve all of these problems, and that's the periodic table, and that's to convert grams to moles of the same substance, and the mole-mole ratio. And that's the piece that we have to use in order to convert between two different chemicals. So one way that we can approach stoichiometry, so molecular weight, maybe you'll use it, maybe you won't. So this way of approaching stoichiometry is going to help you find the pieces that you absolutely have to use, and then you can determine if you need to use the molecular weight to convert to moles or away from moles. Okay, so the two things that you are always going to use in every stoichiometry problem ever, guaranteed, is the given and the mole-mole ratio of those two, the two chemicals. So we can tell that this problem, how many grams of S8 will be needed to make 100 grams of Ag2S. We can tell that this is stoichiometry because we're relating two different chemicals, S8 and Ag2S. We're given an amount of one, and we're figuring out how much of another. We're also given a balanced chemical equation in this example, and if you weren't given a balanced chemical equation, we could easily balance that by watching one of those other videos. But here we can just quickly check. There's 16 silver on the left on the reactant side, and there's 8 times 2 is 16 on the right on the product side. On the left, there's 8 sulfur. On the right, there's 8 times 1, that's 8. So there's 8 sulfur atoms on the right. So there's equal numbers of silver and sulfur on the reactant side and the product side, so this is balanced. And that's really, it's just nice to check before you get started. Okay, so now the important part is we only have 2 chemicals listed in this. So in this balanced chemical equation, we're really going to focus on just those 2 chemicals. So here's S8, and I've included its coefficient. Remember, its coefficient is 1 if there's not a number listed there. And Ag2S is the other one, so its coefficient is 8. So from this tells us the mole-mole ratio. And so that's what we get from the balanced chemical equation. That's why we balanced it. So this is like our recipe. So we know that there's 1 mole of S8 is going to equal 8 moles of Ag2S. And so this isn't something that you memorize. This is something that you take literally verbatim from the balanced chemical equation. So the other, and we are absolutely 100% going to use the mole-mole ratio. Okay, the other piece of information that we can get is the given. So we know that we are starting this process with 100 grams of Ag2S. So we know that we have 100 grams of this, and we want to figure out how many grams of that we can use. So really, we're not going to be able to compare these through any other way than the mole-mole ratio, and that's the key tenet of stoichiometry. So we know that we are given 100, let me just add that in, 100 grams of Ag2S, and we know that's how we're going to start the problem. And we know that the mole-mole ratio that we have to use in order to compare our 2 chemicals is 1 mole of S8 equals 8 moles of Ag2S. Okay, so now that we have those 2 pieces of information, now we can set up our ladder. And the way that we're going to set up our ladder every single time is the most steps that you could that you would need in a stoichiometry problem is 3. So in this first spot right here, that's where the given goes. So I'm going to go ahead and erase that, and I'm going to write our given right there. That's the 100.0 grams of Ag2S. We can also write what we want over here on the right, just so we can keep an eye on that and make sure that we're heading in the right direction. So whatever we want is going to be also listed in the problem, and this is the units that we're going to have. So we want how many grams of S8. So we want the number of grams of S8. So that's what we wrote right here. So we are given 100 grams of Ag2S. How do we get to number of grams of S8? And the answer is we're going to have to use the mole-mole ratio, and we're going to have to use that given. So if you start your problem by writing out the given and your mole-mole ratio, that could be a really important compass. If you don't use both of those pieces of information, you're in trouble. So the molecular weights, maybe you need them, maybe you don't, but you're always going to use the given and the mole-mole ratio. So get really comfortable identifying the given from the problem and the mole-mole ratio from the balanced chemical equation. Okay, so we were given grams. And the next thing we have to remember is that units only cancel if they are exactly identical in terms of the unit and the chemical from top to bottom. So we know that we have to use this mole-mole ratio, and the units there are moles. So we know that grams is not going to cut it. So what we're going to do is we're going to have to convert from the grams to the moles, because the goal is to be able to use the mole-mole ratio. That is our first primary objective. So from these grams, we're going to convert to moles. And how do we do that? That's where we use the molecular weight of Ag2S. And the important thing to remember here is that the molecular weight is always going to be per 1 mole. And we can write that 1 mole on the top or 1 mole on the bottom. In this situation, if you're given grams, the 1 mole is always going to be on the top. Ag2S. And from the periodic table, we can add up that there are 2 silver atoms. They both have a mass of 107.87 grams per mole. So 2 times that, and we're going to add in the mass of sulfur, which on the periodic table is 32.07 grams per mole. So we get our total mass of 247.81 grams of Ag2S per 1 mole. And so that's where the molecular weight fits in, and this is always per 1 mole. And I do realize that in the mole-mole ratio it says that there's 8 moles there, but that's a completely different thing. The molecular weight is always per 1 mole. So don't let yourself get confused there. This is just from the periodic table, and everything from the periodic table is per 1 mole. So this allows us to cancel grams of Ag2S with grams of Ag2S. So now our units are moles of Ag2S, and that is exactly what we want. So our goal number 1 is to get moles. Goal number 1. Get number of moles of the given. And why do we need that? We need the number of moles of the given so that we can use the mole-mole ratio. So if you're given moles, you can totally skip this step. So that's why the molecular weights are optional. Because if you already have moles, do you need to do any math to get moles? No, that'd be too much. Too much math. Why make it harder? Okay. So now that our units are moles of Ag2S, the next thing that we do is goal number 2, use the mole-mole ratio. So we've already got the mole-mole ratio written out. 1 mole of S8 equals 8 moles of Ag2S. And remembering that the units have to cancel exactly top to bottom. We know that on the top here we've got moles of Ag2S. So you can take a moment and predict which one's going to go on top and which one's going to go on bottom in this middle piece here where the mole-mole ratio is going to go. Okay, right here's our mole-mole ratio. And because the moles of Ag2S are on top, we're going to put that part on the bottom. And this part you're just copying exactly. This was an opportunity to write it in red, Dr. Poe. Okay, so this, and these numbers come exactly from the balanced chemical equation. Even if they could cancel or something like that, I never do. Just because if I cancel it in my head, I'm worried that maybe I did the math wrong. So I just write it down exactly verbatim. So this is 1 mole, because remember if there's no number there, it's a 1. 1 mole of S8 and 8 equals 8 moles of Ag2S. That's our ratio. That's our recipe. So if we had to double this, we would double both parts. Okay, so now the units that we're left with, so moles of Ag2S will cancel with moles of Ag2S top to bottom because the mole is exactly the same and that chemical is exactly the same. That's the only way that you can cancel. And now the units that we're left with are moles of S8. Is that what we want? No, we want grams, and grams and moles are different. So what we want next is the molecular. How do we get from moles of S8 to grams of S8? Well, that answer should be obvious. How do you think? So you can pause the video and think about it. What piece goes here? And the answer is the molecular weight of what we want. And so what we want is S8. And remember, every molecular weight from the periodic table is per 1 mole. So that's where that's going to come from. And we're going to cancel the units top to bottom. So moles of S8 are going to cancel with moles of S8. It has to be exactly identical. And we know that each sulfur atom weighs 32.07 grams. And there's 8 of them, so 32.07 times 8 is 256.56 grams of S8. That's how much 1 mole would weigh. Okay, and when we're all done with this, now you can see that all of the units have canceled top to bottom. Grams of Ag2S cancels with grams of Ag2S. Moles of Ag2S cancel with moles of Ag2S. Moles of S8 cancel with moles of S8. And we're left with grams of S8. So now we plug this into our calculator, 100, and you don't have to times 1, but you can if you want to. If that's your process, do it. Times 1 times 256.56, and without pressing equals on your calculator, you can hit divide by 247.81. And without pressing equals on your calculator, you can hit divide by 8. And then when we round our final answer, we get 12.94 grams of S8, because that's the units that are left. Everything else canceled. And the pattern that we used. So in this problem, we wanted grams of S8 when we were given grams of Ag2S. Our first step was we wrote out the given from the problem, and we figured out the mole-mole ratio. And that mole-mole ratio is from the balanced chemical equation. 1 mole of S8 is 8 moles of Ag2S. The first thing we wrote down in our ladder was our given. We determined that because the given was in grams, we had to use our goal number 1. We had to get the number of moles of our given. And anytime you're given grams of something and you want moles of something, you have to use the molecular weight. So that's why we use that first in this particular formula. So why did we have to get moles? Because our second goal is to use the mole-mole ratio, and those units have to be identical. The mole-mole ratio is in moles, so if you don't have moles, you got to get moles. So we got our moles, we used our mole-mole ratio in our second step here, and then when we finished our mole ratio, that gave us our answer in terms of moles of S8, but that's not what we wanted. We wanted grams of S8. How do you convert moles of S8 to grams of S8? You use molecular weight of S8. Okay, so I hope that this pattern of writing out the given and the mole, you saw where both of those were used, mole ratio. You have to use those. The molecular weight, maybe you need them, maybe you don't, but you can absolutely figure that out based on the problem and your knowledge of the periodic table. Okay, I'm going to make a couple more videos on this as well.